Hello and welcome back. In the last few videos we talked about what a quadratic function is and how it looks like on a graph. In the next few videos, including this video, we're going to look at different techniques that are very useful when being applied to quadratic equations and will allow us to have a much easier time with sketching parabolas or quadratic functions. So the technique that we're going to be going over in this video is called simple factoring. And before we go over factoring, I'm going to briefly review distributing because I feel that it will really help us understand how to work with factoring. When we went over distributing, we basically talked about how if you have a number in front of the brackets, you multiply that number by every term in the brackets. So in this case we have a 3 outside of the brackets and we will multiply it by every term inside the brackets. So we'll have 3 times x and then 3 times 4. 3 times x is 3x and 3 times 4 is 12, so that will give us 3x plus 12. Okay, similarly with 5 times 3x minus 2, again we will distribute the 5 to every term in the brackets. That will give us 5 times 3x minus 5 times 2. 5 times 3x is 15x and 5 times 2 is 10. So that will give us 15x minus 10. And again, I'll include some color coding to help you better visualize it. Okay, so that is how distributing works. If you have a number in front of the brackets, you multiply every term inside of the brackets by that number. So how does factoring work? Well, I like to think of factoring as the reverse of distributing. So why don't we start off with 3x plus 12 this time. Okay, so the idea here is that we're going to look for the common factor in each of the terms. So we can't really break down the 3x at all, it is just 3 times x. But 12 does have a common factor, and that common factor is 3. Because we know that we can rewrite 12 as 3 times 4. And we can then factor out the 3 to write that as 3 times x plus 4. And you'll notice that if I distribute the 3 to the x and the 4, I'll get back 3x plus 3 times 4, or 3x plus 12. So that's why I called it the reverse of distributing. Same idea with 15x minus 10. What is the common factor for 15 and 10? Well, it's 5. So we can rewrite 15x as 15 times 3x, and we can rewrite 10 as 5 times 2. So the common factor is 5, and we can factor the 5 out of that expression to leave us with 5 times 3x minus 2. And again, I'll include the color coding so we can see just how the numbers or common factors are factored out of the expressions. And again, we can see with the 5 times 3x minus 2 that if we distributed the 5 to the 3x and the 2, we would have 5 times 3x and 5 times 2, which would give us 15x minus 10. So again, that is why we sometimes like to look at factoring as the reverse of distributing. So the main idea is that you find the common factor and then you factor it out of the expression. So I'll go over 2 more examples. So we can apply factoring to quadratic equations as well. In this case, the common factor for 8, 2, and 10 is 2. So I can rewrite 8x squared as 2 times 4x squared. I can rewrite 2x as 2 times x, and I can rewrite 10 as 2 times 5. So the common factor is 2. I can then factor out the 2, and I'll have 2 times 4x squared plus x plus 5. Okay, so it's basically the exact same idea when you're doing quadratic equations or quadratic expressions. One more example. So the difference with this example is that each term has an x. And what we'll find is that we can actually also factor x terms. So normally in this example we would first look at the numbers. We see that 9 and 18 have a common factor of 9. So we can rewrite it as 9 times x squared minus 9 times 2x. Okay, so the common factor is 9. We can factor out the 9 from that expression, and we'll have 9 times x squared minus 2x. Okay, so the other thing that we have to keep in mind is that if every term has an x, then we also have to make a point of factoring out the x. Okay, so we keep in mind that x squared is x times x, because in general anything squared is that number multiplied by itself. So we have that the expression in the brackets can be rewritten as x times x minus 2x, and then we can factor out the x, and we'll have 9x times x minus 2. Okay, so I showed the color coding on the 9 terms to show how we factored out the 9. And I can also show the color coding on the x terms to show how we factored out the x. So that is just something in general to keep in mind, that if each term has at least an x, then you have to also factor out the x. So that is all I wanted to go over for this video. In the next video, we will look at some other common factoring techniques that are used for factoring specifically quadratic equations. But for now, as always, thanks for watching.